Hello, everybody. Brian here, quantlabs.net. I wanted to go over this article I just posted about SIMD. Is it the most high performance, highly optimized method in C++ for something like high frequency trading? Put some mentions in my book here. If you want to get that, it's free. Just go to the Learn tab at quantlabsnet.com, get on that, opt in, and then you'll get your copy. Coming back to this article here, I posted what it is, single instruction, multiple data across multiple processors. Essentially, there was an article posted here, kind of explains it. Um, Again, I'm no expert on it yet. Uh, I haven't really looked into this outside of what I'm posting here. I just wanted to show that really what it boils down to is two things: the compiler itself, compiler intrinsics, language specific constructs that map SIMD instructions. And basically, that means that it depends on the library you use and the processor you're using and the compiler. So we have pre-optimized SMD uh, implementation for common math and signal processing operations. So these could be specific to compiler or to a um, or a processor. So you can see here IPP library and AMD libm as well. So they're specific to the hardware that you're sitting on, what you're targeting. And as I said, these libraries can significantly simplify SIMD programming and improve performance. So again, you have to look at the specific hardware that you are targeting on with your source code in C++. Um, so what can this be used for in the context of high frequency trading? Numerical computations, kind of like a CUDA with the Tesla. If you have looked at my most recent course that I put out, I have shown that uh, on specific demos. I mean, it's kind of old, but it's still valid with CUDA, Tesla boards, and C++. Also, calculating moving average or standard deviations can be significantly sped up using SIMD. So even on specific mathematical operations, this can quickly improve processing. Also for array initialization, copying, and sorting. The book that I'm reading covers that as well. These are significant improvements with C++ 17 and better optimized again, depends upon the hardware and the compiler you're using. Multiple elements in parallel. Uh, so it reduces the time taken to operate, signal processing, um, implementation of filters, Fourier transforms, and other signal processing algos. Again, the course that I mentioned here um, covers that in MATLAB demos with signal processing in MATLAB. It's pretty easy to work with, but I wouldn't be surprised in this day and age, MATLAB specifically in their libraries have it automatically optimized based upon the processors that you're using. Again, I have to look at that. Again, here, string processing, uh, HFT operations don't or try to minimize, probably even eliminate strings in their coding. Accelerating string operations like searching, matching, and parsing. I just don't see how HFT shops would use strings, but what do I know? I'm not in those operations. So here, the vector size is important. Uh, Vectorization with specific loops. I've shown, I think, a demo, might have actually a post of an example of looping where you don't use a for loop or a while loop at all. SIMD instruction set. So here's some examples: SSE, AVX, so on. based upon the target processor. Compiler optimization, I've already kind of covered that. Specifically, do your own research, as I say. Profiling tools to showcase the bottlenecks and measure the impact of these operations. Um, so here I've got an article. This is what initiated it, was on Reddit. SMD may not be the fastest approach. So the summarization is using JSON parsing. Have no idea what that would be for. Um, some people believe that SIMD is not the fastest approach for parsing JSON because it requires iterating over values twice. So again, that's specific, using JSON along with JavaScripting as well, it seems, or just JSON, I should say. Um, Good approach for parsing. So specifically, that's what that is. So I have looked at C++ experimental stage, it looks like, with this SIMD library. I'm not sure what version for C++ this would be for, but it is being discussed version 2. So I guess it's not final, nothing implemented yet, but would be an interesting area to look into if that's what you want. So again, if you want to know more about what I'm doing and that ebook on HFT, just go into the Learn tab at quantlabsnet.com, get it there. And other than that, hopefully I'll help you out. We shall talk to you later. Have a good day.